what is chemical bonding? So a good definition is that it's a force that strongly attaches one atom or ion to another and thus lowers the energy of the system. So if you look here, this word attaches, and then you have lowers the energy of the system. Systems in nature would like to have low energy. So low energy results in higher stability. So keep that in mind in science, especially in chemistry, is you need less energy to get more stability. So let's look at a bond here. You know that if we have a nucleus, there's a nucleus, you have two different atoms. Nucleus is positively charged. Here's the electron in the orbit or the orbital. And as those two atoms approach one another, something happens here. And what happens is that they experience the force of attraction, the electrons, from both nuclei. Okay, so if you notice here, this electron and that electron are only, before the bonding, are only attracted to one nucleus and one positive charge right here. Same with this one. But what would be better than actually having the electron now being stabilized by two positive charges? You see them right here. Same thing. So again, this negative attraction holds the particles together, and that ends up lowering the energy of the system. We learned from quantum mechanics and from the previous, again, chapter chapter 8, that there are valence shells, and those again are not as stable as the inner shells or the core shells because they're away from the nucleus. So one way to compensate for this is to add another nucleus, or to have a nucleus with a positive charge nearby where it actually can stabilize the electrons in the valence shells. So the attraction is called a chemical bond. One pair of electrons constitutes one bond. Once again, it's better to have, in a nutshell, just quickly, two positive charges that stabilize the negative than one. So what is bonding based on? Bonding is based on valence electrons. And we did talk about valence electrons before, electrons that occupy outermost, highest in energy orbitals. So if we look at something like lithium, this is 1s2, two s1. My valence, the outer, is the one with the highest energy level, which is the 2. So that means I have one valence electron. We did that plenty of times before. Well, what are we concerned with is I need you to be able to get the valence electrons right away. Be able to do it this way, which you've done in the last lecture. But now what you need to be able to do is get them from the periodic table quickly. And here's how you do it. You go to the periodic table, and all you have to do is find the element in the group, and the group number is going to give you the number of valence electrons. So for example, group 1 right here, group 1, this is group 1, even including hydrogen in this case. These have one valence electron. So all of these have one valence electron. So I'm going to write one valence electron. Group 2, just here it is, that's one valence. Now group 2 means you have two valence electrons. VE means, again, valence electrons. Now we skip ignore these. Again, you'll learn about their chemistry in Gen Chem 2. You'll learn that you jump to group number 13, and you have the choice. You either continue counting, this would be 3, 4, 5, 6, 7, 8. Of course, helium is 2. Or, so you look at the second digit. So let me expand this so you can see it. This is a 3. This is a 4. It's a 5, a 6, and a 7, and an 8. You can think of the effective nuclear charge. Or even if you forget, look at the Roman numeral. You have 3, you have 4, you have 5, 6, 7, and 8. So these are the valence electrons. So very well, if I say, well, I need the valence electrons of carbon, how do I find them? Well, instead of writing this out, 1s2, 2s2, you still have to do it for, practice purposes and knowing the electron configuration. And you know that this is the highest energy level. It has 2 sublevels. So that's 2 plus 2 is 4. All I can do is just look at this number right here. So I find carbon. It's in group number 14. Either I look at the second digit or I look at the Roman numeral. So that's 4. So once again, that would be 4 valence electrons. Okay, let me move this out of the way. If I look at the oxygen, well, I go and find oxygen. That's in group number 16, but I look at the 6 or 6A, so it has only 6 valence electrons. What about sulfur? Sulfur is underneath, but it's still in the same group. So again, I'm going to just write them here. 3, that's 4, that's 5, that's 6, that's 7. And all of these noble gases are 8, with the exception of helium, which is only 2. I mean, it only has 2 electrons. How can it have 8? So O is 6 valence. I look at the Roman numeral here, 6, or the second digit, or I continue counting, 1, 2, 3, 4, 5, 6. So again, S has 6. So this is a pattern, very important, one of the most important patterns. Okay, I'm just going to do 2 more. What if I look at P? How many valence does it have? Well, here it is, P. It's in group number 15. I look at the 5 or the Roman numeral 5, and that means I have 5 valence. Once again, valence means the outermost, and these are the ones that are most important for bonding. And if I have Br right here, Br, how many valence? I just look at this group. Group what? 7. Here it is. So I have 7 valence. So be able to do this. It's quite easy. You just have to look at the periodic table. But this is incredibly important. So let's go back. That results in what we call Lewis dot structures. So Lewis dot structures simply are a way of indicating the valence electrons. And the valence electrons in this case are shown as dots. So let's look at H. If I look at my periodic table, and I know H right here has 1 valence electron. I know this is blocking it, but again, this is 1 valence electron. So what I would need to do is just simply take a dot and draw it there. Okay. Helium, if you look at your periodic table, you see that it has 2 valence electrons. That's the second one, second simplest molecule. So I have 1 and 2. You make it as symmetrical as possible. B is boron. Has 3 valence electrons. So that would be 1, 2, and 3. Carbon, 4 valence electrons. Nitrogen is 5, oxygen is 6, fluorine is 7, and neon is 8. So you have carbon, 1, 2, 3, 4. Make it symmetrical. N is next and has 5 valence electrons. So you go 1, 2, 3, 4, and then you just find any, doesn't matter where, and you attach you add the 5th electrons. So now you have a paired, they're paired here. So that's 5 valence electrons. Oxygen we said was 6. So that would be 1, 2, 3, 4. And then again, you want to make it symmetrical. So here it is, 5 and 6. Fluorine has 7 valence. So that would be 1, 2, 3, 4, and then 5, 6, 7. And then finally, neon has 8 valence. So that would be 1, 2, 3, 4, 5, 6, 7, and 8. There's something special about neon, noble gas. Notice that it has a pair of electrons on each side.